Okay, good afternoon, everyone. I am Philippe Willekens from the European Space Agency, Head of Communication, and we are here for about an hour on the press meeting with journalists from all over Europe. Thank you for being there, despite the difficulty of handling everything on a video conference. I'm happy to have ESA Director General Jan Wörner here for answering questions. We also have Dave Parker, the Director of Human and Robotic Exploration Directorate in ESA, and Francois Spoto. They are both on different sides. Francois Spoto is the ExoMars Project Manager. So with this, the process of these unusual press conferences that I will be the spokesperson of the journalists, since we don't have the possibility to have everybody online. So I received a question, and I will channel the questions to the to ESA Director General. Also, we must indicate that the Director General of Roscosmos, Dmitry Rogozin, could not attend this press conference for technical reasons, and therefore convey us all the apologies for that. Also, we managed to have a joint press release, which now should be issued on the ESA website. So, again, welcome to everyone, and sorry for all the glitches which will happen in the next hour. This is unusual circumstance, so thank you, ESA Director General Jan Wörner. So we will start immediately with questions from RIA Novosti. So this is Valentin Rastatov.
Should I not introduce a little bit first?
Oh, yes, sorry, you're right. So we'll keep the questions for a moment, and of course, yes. Let's give some word of introduction.
Of course, I understand that you have very clear questions, but I would like first of all to set a little bit the scene of what we are discussing today. So as you heard, not in Moscow, I'm in Paris because of all these coronavirus issues. But we had a long discussion today with my friend and colleague Dmitry Rogozin, discussing about all the different aspects, the status of the ExoMars rover and the surface platform mission. And what is for me the very most important aspect of this, we are looking really for a very special and challenging, inspiring mission, which is from a scientific, technical point of view, really something very special. We would like to make a 6 months trip to Mars, surviving the heat of entering into the atmosphere, landing safely a rover, and drill into the surface of Mars to look if there is something like life, or something that there was something like life, which is really a big question also for humankind. So why are we doing it? That's always a question I get here and there. The first thing is we are doing it because we are curious, but also we are doing it because it's a challenge both in technical as well as in scientific ways, scientific points of view. And of course, if we find something like life on Mars, this will change our understanding of the universe in a dramatic way. We are doing this in partnership, especially in partnership between Russia and Europe, but there are also other partners on board. And international cooperation is part of our DNA, part of the DNA of ESA. So we worked on this project for many, many years. There were some hiccups, some problems, and we had to solve them. But what is very clear, and this was today confirmed also by Dimitri and myself, that we have the trust, the mutual trust today, and only with this trust we can make really a success story. So within the situation we know that there are several aspects we have to do. We need a safe launch of the mission, and therefore we ask several independent actors also to help us. So for instance, the ExoMars Tracking Committee, including representatives of our member states, of ESA member states, and also the Inspector Generals to give the Director Generals the information where we are. So where are we now? It's very clear. The Russian Proton launch vehicle and the European carrier spacecraft are complete and ready to go. So this is a good message. The European rover, Rosalind Franklin, has demonstrated good performance in environmental test campaign. We have proven its ability to survive the harsh condition of launch, landing, and especially also operation on the surface of Mars, which is not comparable to a street or road on Earth. All its instruments, including contribution for research institutions around Europe, Russia, and the US, have been included in these tests. Extensive tests have also demonstrated how the rover can drive off the lander, over rocks, as I said earlier, and even use its wheel walking to get out of trouble. So not only wheels like normal wheels, but so they can also be in a very special walking mode in order to overcome any problems. Autonomous navigation software is being finalized for comparative testing on Mars. Once ongoing testing in Cannes is complete, Rosalind Franklin will return to Torino to make a small fix to its solar array. And this is now very well known what we have to do, so this question is also solved. Meanwhile, the Russian lander has already been tested in a special platform that drops it onto a simulated Mars surface to prove the landing decks. The Russian and the European science instruments for the lander have also been delivered and added to the spacecraft. And just 2 weeks ago, the descent module propulsion system completed a hot firing test in Russia. So all of the flight hardware for the descent module and lander platform is built and integrated, with the exception, as you know, of the parachutes. The parachutes, special problem we had with the parachutes in our first parachute test. Now 2 high altitude parachute tests will take place very soon. We are using a US test facility company, but there are some competing priorities over there, so this will be a little bit later than we hoped we will get it, but obviously until these tests are successful, we have a remaining risk in that. In addition, the testing we have been doing has also shown some technical bugs with 4 electronic equipments in the descent module, so there is still work to do. We need these electronics because they have to fulfill critical functions like depressurization at liftoff, power and thermal control, propulsion system, and parachute commanding. So therefore, yes, they were required to be returned to their supplier. Due to the troubleshooting of anomalies with these equipments at system level, the final version of the flight software has been delayed, and there is not enough time left to fully test it before a 2020 launch and gain the confidence we need. So we could launch, but that would mean we are not doing all the tests, and from the experience we had with Beagle and Schiaparelli and the clear messages I got also as a Director General, that was a very harsh, clear message: do all the tests before you launch. So although we are really close to launch readiness, we cannot really cut corners, and I will come back to that in a minute. After carefully reviewing the reports we have received, we have together accepted the advice that launching this year would mean sacrificing essential remaining tests. And as I said before, we have to do that. So we have therefore jointly, the Russian side and ESA, that means the Director General of Roscosmos and myself, decided and today confirmed this decision to move the ExoMars mission to a later launch opportunity, namely 2022. This is a very tough decision, but it's, I'm sure, the right one. Why 2022? So because of celestial mechanics means that we can only launch to Mars approximately every 26 months. So missing just a few weeks means we have to go to 2022 as an earliest possibility. So this is not, we cannot say, okay, we are launching 1 month later or so. That's just not possible because of Mars and Earth having different orbit times around the Sun. So we will have in 2022 the same launcher, the same landing site, the same planet, Mars, and also the same mission profile as we planned for 2020. We are directing the joint European and Russian team to work together to complete all remaining tasks. This was confirmed today in detail between Mr. Rogozin and myself. We will, as soon as we are ready with the spacecraft, we will store the spacecraft until preparations restart for launch in the 2022 launch window, which is between August and October in 2022. Meanwhile, and this is the positive message, the ExoMars Trace Gas Orbiter continues to deliver excellent science from its instruments and is also relaying data for NASA's Mars mission Curiosity and InSight. So the Trace Gas Orbiter is working, is delivering excellent science. And the good thing is, of course, we also raised the question, is the TGO, which we need also for the 2022 launch, is it still feasible to use it at that time? Is there enough fuel? And what about all the technical aspects? So it's in a very good health situation, the TGO, and it has enough fuel reserves, so there is no issue with that. And the big fuel reserves are especially because of very smart operations to enter into the orbit around Mars. So all of this is fine. But of course, it's a huge disappointment to each and everyone, to the scientists, to the teams, to the engineers, and also to myself, because the teams have been working so hard to make the 2020 launch. We forced them the last months even more, working in 3 shifts and all of this. So I really would like to thank also these teams, especially also in Europe, to do whatever they could in order to make it possible to have this launch. But also our Russian colleagues worked very hard. So unfortunately, this is now a different situation. So, but instead now to share the disappointment and scream and cry, we are looking forward to make the launch in 2022 possible, because we are really talking about a really very fascinating mission, and we have waited for centuries to find out if Mars is something like the early place of life in our solar system. And therefore, to find an answer to this question, we are still going to have some more patience for a couple of years, 2 years. But it's important to go on and not now stop all the work. So we agreed that we will go on as fast as possible to make the spacecraft ready for the 2022 mission. Thank you for your attention.
Thank you for this introduction. So we are going to move into the question and answer. For all media following us, if you have a question, please raise it to media@esa.int. So send your question to media@esa.int. Therefore, we are monitoring all these questions, and I will relay these to our Director General. So while you're doing this, I have already received a couple of questions, which I will take them in the order of submission. So the first one comes from Russia, and it is requested by Valentin Raskatov from RIA Novosti. So the question is about the repairs that was encountered with the rover. It was done in February, some reparation there, and he asks, is Rosalind Franklin now ready for the mission?
My information is all this repair work is very well done, but I would like to ask David to answer that question.
Thank you very much, and good afternoon. Do you hear me well?
Yes.
We hear you. We hear you well. Yes.
Very good. So you're correct that during the full environmental testing of the rover, which has been completed and is considered very successful, there is a minor debonding of some solar arrays on the rover. We had seen this problem in earlier testing and had anticipated the need to make a modification, which is to add some additional mechanical fastening of the solar array to its backing structure. That work is to be carried out, is not yet carried out, but is planned to be carried out when the rover returns from the system level testing in Thales in Cannes to the prime contractor Thales Alenia Space in Torino. So it's forward work that is planned.
Thank you.
Thank you, Dave. And as a side question from the same person, Valentin Raskatov, there's a request to understand what are the remaining tests which needs to be implemented for the rest of the mission.
So this is a very detailed question, and again, I would like to David to answer it, or Francois. Please, David.
So I'll make a brief introduction and then to hand over to Francois Spoto. So most of the environmental testing has been completed. That's thermal balance, thermal vacuum testing in the chamber. The rover, as I said, has completed its testing. The carrier spacecraft finished its testing some while ago. What we have left in front of us are mostly related to avionics and system level testing of the functionality of the spacecraft as opposed to its mechanical and environmental performance. So maybe Francois, you could say a bit more about the remaining tests and the retrofit of some of the equipments.
Okay, good afternoon, everyone. So the focus as we speak is on two places currently. In Cannes, where we complete the environmental test campaign. And as we speak, we are finishing the EMC campaign, electromagnetic compatibility, where we check that all the modules put together, carrier, landing platform, rover, are from an electromagnetic compatibility viewpoint working well together. And then we will complete with what we call mass properties characterization. You should realize that the cruise phase will be based on a spinned mode of transfer, and therefore the repartition of mass and the mechanical properties are very important to be known in order to accurately control the 6 months cruise phase towards Mars. And we have a special machine in order to characterize those data. So this is a focus in Cannes, South France. In parallel, of course, we have some software development activities that are ongoing as well. There in Torino, where our Thales Italy prime team are turning the requirements applicable to the central software into a software, and the software commands all the modes of the mission. So it's essential that when completed, the software is very, very thoroughly validated in order to verify post-separation, cruise, separation CMDM close to Mars, entry, descent and landing, and the surface operation of the landing platform. So those are the main activities that are currently ongoing. To complete software, of course, at a point in time, we will need to make a test on the protoflight model of the spacecraft, meaning we have to wait that those 4 equipments that needs to be repaired are repaired, reaccepted, and returned for integration into a fully clean spacecraft configuration. And this is one of the main reasons, by the way, why we are not ready without any risk to launch in 2020. It's because we need to troubleshoot those equipment, finish the software development, and combine the two together to demonstrate before launch that we have a safe mission that can cruise and land on Mars.
Thank you.
Thank you very much. So next question is from Jonathan Amos from BBC. So any implication which could result out of the storage, in particular focusing on materials on the rover?
I'm happy that most of the questions were also the questions I raised to the experts, because that shows that I'm not out of this world. But instead of giving my layman answer, I would like Francois to give the answer to this question.
Of course, the knowledge that it is a bit short to launch in 2020 is not that old. We've been keeping pushing up to, let's say, 1 month ago. Therefore, the thought about whether we have specific activities to do on the rover during, grosso modo 2 years of storage is just starting. I would say that from my current perception from the teams, we have not on board the rover any materials that would basically vanish in the next 2 years and prevent basically to launch. But we have to be very cautious about things like the lubrication of the mechanism. The rover is full of mechanisms. We have an integrated laboratory on board the rover, which serves several of the payload instruments, including the big American instrument MoMA. And we have to make sure that all the distribution chains, the carousels that transfer the samples digged out from 2 meters depth within the laboratory are well distributed, are well mashed, are well burned to evaporate the gases that we want to analyze. So all those things will probably lead to periodic awakening of the rover and verification of some activities. But I don't believe we will have to change equipment in that storage frame. But this is still to be demonstrated, of course. We have, in any case, some spare kits in case some of the elements would have to be changed. A point where we have to be extremely careful as well is the problem of cleanliness. Discovering life traces from Mars requires an extra clean environment to make sure that what we discover on Mars is not simply what we brought from Earth. And therefore, the rover will be stored in a very clean environment, this ISO 7 special chamber in Tassai, Torino. And there we will have also to make sure that we flush permanently the ultra-clean zone and maybe even have to make an outgassing activity in order to make sure that pollutants are all evacuated before making the rover ready again to be transferred to Baikonur for launch. So this is today what I can say, but the work in defining in details what the rover has to encounter during the storage phase is starting.
Thank you, Francois. So let's move to the next question, which was raised by Thierry Dubois from Aviation Week. Can you say why 4 electronic units for the descent module were returned to the supplier?
So there was some malfunction, and this is the reason we are doing the tests. I mean, otherwise we would not do a test if we are sure that nothing happens. So there were some tests and some malfunctions observed, and therefore we say return to sender.
Okay, so Jonathan O'Callaghan from Nature, is there any possibility that any instrument could be added to the rover in the next 2 years? And will any aspect of the rover will be changed or upgraded?
So my opinion, but I have just a personal opinion, is that we should not change the setup of the mission, because then we are starting a new qualification test, etc. But I'm not an expert in that field. David?
Yes, thank you very much, Jan. So, no, there would be no intention to change the instrument suite. The instrument suite has been carefully developed as a combination of instruments that go from very low resolution cameras to view Mars, all the way down to molecular level analysis inside the laboratory on board. And so there will be no possibility at this stage to make a change. The rover has been finished, the rover is complete, and with the minor changes needed is ready to go. And likewise, the Russian lander platform has instruments from both Russia and Europe. Those are all finished, integrated onto the lander, so no change to the science content.
And one should see this, if one has time, one should see this rover carrying a full laboratory. It's really impressive to take the samples from the ground and then to really inside the rover to investigate them. That is really masterpiece of engineering.
Good. Marie-Ange Sangui, this morning we heard that there were some problems on Proton. Was this one of the reasons to postpone the mission?
No, this was not the reason, but we tackled also the question of the Proton launcher, and it was confirmed by the Russian side that the Proton launcher will be available in 2022 for this launch.
Regarding the parachute and the parachute test, here's a question from an Irish TV, Leo Enright. Can you outline in detail the status of the parachute development, and how did the recent test in the US go? Was it a success, or more tests are needed?
Maybe that was a misunderstanding. Again, I start, and if there's some corrections from Dave, please don't hesitate to correct me. So we did some parachute testing last year, and we found out that there were, and these were drop tests, means from a high altitude parachute were tested, and we found some damage at the parachutes, and then the investigation showed that it may be from the unpacking of the parachute. So this was changed. Then there were some ground tests done in the US, and they looked much better. I have to thank, by the way, also our NASA colleagues, because they gave us big assistance to that. And now we would like to do final drop tests again in the US. These are not done so far. They were planned to be very soon. Now it will be a little bit postponed, but we are talking here about weeks, not about months. David?
Thank you, Jan. Yes, that's all exactly correct. So the ground tests were extraction tests showing the pulling out of the parachute from the bags. We believe this was the problem that we saw in the drop tests last year. I should say the parachutes themselves have been shown to function well. The issue was around the extraction of the parachutes from their bags. The 6 ground tests with the 2 different types of parachutes have given us much more confidence for the way forward. Thank you.
Thank you, Dave. So next question is regarding the storage. So this is coming from the Register UK, Richard Speed. What is involved in storage of the spacecraft, and will any components have shortened life once it arrives on Mars?
So the idea is, and that Francois was saying it, that of course so far we did not plan to have the storage. Therefore, we will have a look in details. If there is a specific component which might have some special issue, then we can still change it before the launch. So there is enough time. But so far there is no issue seen that that this might change the lifetime or whatever. Is it right, Francois, what I'm saying?
Yes, I'm on your line on that question, exactly.
Whether it was again the question whether there is a lifetime reduction of components due to the storage.
So far we don't think so, but it has to be further studied.
Okay, this is what I said. Okay.
Okay. Good. There was a side question from the Register UK from Richard about the cost of the delay, Jan.
So we promised to our member states that we will not come back with additional bill for that. We have some contingency, but again, in this respect, Dave is the Director for Human and Robotic Exploration, and I'm sure he can make this answer even better than me.
Thank you again, Jan. Yes, I take the responsibility for all of this situation. So there is no final cost assessment for the delay, pending the negotiations we'll need to have with industry. But as you said, Jan, we highlighted the risk of a delay. We like to be cautious in our financial planning. ExoMars is within a larger financial envelope of space exploration. So we identified a risk mitigation budget when we, the Director General and us, we all went to the ministerial conference in Seville, Space 19 Plus. So that risk mitigation budget was included in our overall Mars exploration program that was fully funded at Space 19 Plus.
I can at this point I can add also that this mission is also very important because we are also looking forward at the later time to have a Mars sample return together with NASA, and of course then we have samples from Mars, and when we have investigated now with ExoMars clearly what happens, is there life or something, then we know also what we have to do with the Mars sample return, where we have to look in more detail. So it's also a part of this story, so the Mars sample return remains on our agenda as planned.
Good. Frank Willekens from golem.de. What drove the decision to use the largest parachute ever flown on Mars on ESA's first major Mars lander mission? So what has ESA learned from these problems in its approach on other missions using technology in which ESA is lacking prior experience?
Yeah, but you cannot say I'm just using a smaller parachute because I don't have enough experience with it. The size of the parachute depends, of course, to the mass you have to bring safely to the ground. Dave.
Yes, yeah, and exactly right. So there have been a number of previous European missions using parachutes of different sizes. In fact, we have two main parachutes on ExoMars. Then they're large. The largest one is the largest to be flown to Mars, but there are comparable other examples of parachute systems of this size. But the parachutes are sized simply for the function of adequately decelerating the vehicle before we switch to using a propulsion system on the Russian provided lander. Now, of course, we learned a lot from previous parachute activities with Huygens, with Beagle 2, with Schiaparelli, where the parachute functioned fully successfully. And as I think others have noticed, parachutes are a very special technology. As an aerodynamicist myself, flying dynamic vehicles with parachutes is challenging, and several other vehicles have experienced challenges during the parachute development. So we are learning a lot, and all of this is relevant to future missions. We're doing science, but we're also doing technology development with ExoMars and learning what we can take forward to the future. Of course, until you do something for the first time, you don't know all the problems you're going to face, but we are facing the problems and we're solving them one by one. That's what we do.
And it's another example why we are saying we would like to have all the tests prior to the launch, not only the parachute, but also the other tests, because during the parachute testing, we learn something. And the learning curve should be at the maximum when we are coming closer to Mars. So that means we would like to be as sure as possible, as certain as possible when we go to Mars that we have at least done all the tests to show that it is possible to land on Mars. It's really a hard thing. People forget about that. To enter into the atmosphere, you need the heat shield. Then you can have a parachute because you have an atmosphere, but at the end of the day you need also some engines to decelerate for the final landing. So it's not that easy as some people believe, just open a parachute and you can land. They are doing it on the Earth as well. No, it's much more difficult because the atmosphere is thinner than on Earth. Therefore, you need really huge parachutes and at the end also engines, but you have still an atmosphere, so you need the heat shield. So it's really a difficult task.
You allude to the Mars 2020 and the Mars sample return perspective. Leopoldo Benaccio from Solid 24 is asking if, first of all, ExoMars being a complementary mission to this very exciting decade of discovery of Mars, but are there any consequences on these missions, on these plans from these delays?
So there are several Mars missions in the past, but also in the near future. But with ExoMars, we are looking to a very specific point to look to whether there was or whether there is something like life. We know that Mars had a better atmosphere than today, had better climate than today. So there is a chance. Also, the development of Mars was similar to that of the Earth. So to understand whether there was or is life is also some information, not only curiosity, but maybe gives us also some hint about the future of Earth. And therefore it's totally complementary to the other Mars missions which are planned here and there. And concerning the Mars sample return, the consequence is when we go with the Mars sample return, we know already even a little bit more on how to handle all of this. So therefore it's also an additional work for that one. Dave, would you like, from a scientific point of view, add something?
Yes, and I think the question was also how does ExoMars fit into our sequence? Remember, you know that ESA has two missions at Mars today. Mars Express has been there since 2000, and Christmas Day 2003 delivered fantastic scientific results, going from the outside of the atmosphere's destruction, the behavior of the atmosphere, made wonderful images of the surface, but also probing below the surface with its radar and seeking out water. Meanwhile, the ExoMars Trace Gas Orbit, it's the largest spacecraft in orbit around Mars by far today. It's telling us about the absence of certain trace gases on the global scale, in contrast to what the Curiosity rover is seeing of a local presence of methane. So we're on the trail together with NASA of a fascinating question: if there is methane being produced, is it being produced, and how is it being destroyed? And again, the instruments on the trace gas orbiter have given us the best imagery of subsurface water so far. And then looking forward, ExoMars fits into that package because it's going to explore an ancient lake bed, at least 3 billion years old. So it's a time machine as well as a mission to Mars. So, and that's unique because we have a drill to get below the surface. The drill has been proven and works. And so that's a unique step towards Mars sample return, a cooperation with NASA, with 3 launches, the first of them with the Mars 2020 mission. And so I can tell you that NASA is fully informed of the situation on ExoMars because we have an important scientific contribution from NASA on ExoMars. And so they understand the situation, and they respect and appreciate the decision that we're making, just because they've had to make similar tough decisions in the past as to when it's ready to launch and when you're not ready to launch.
Thank you, Dave. Coming back to a question which was already raised, so sorry for those who can feel a repetition, but there's a bit more specific from Jonathan Amos from BBC. He's referring to the fact that the rover is 10 kilograms underweight. So here again, the question is, would we be able to add this on with a camera or with a microphone when we recover after the storage?
Dave?
Jonathan, it's a great question. For those of us who love science, it's always possible to add something more. But this has to be balanced with a program point of view and the engineering. That it would be unwise to start changing the design of the rover at this point. We want to focus on the descent module and getting sure that we're ready to launch the descent module with all of its aspects. So that will really going to be the focus for the next period, next months, to try and finish all of the core engineering work by the end of this year.
The question from exploration, Espace and Exploration, from Marie-Ange Sangui, is actually asking what's going to go after if we meet the readiness towards the end of the year. What are we going to do during this waiting period?
Sleeping. No, that's, of course, we have so many projects at the same time in ESA right now, especially also with Space 19+. We got a big task, not only a lot of money, but also a big task, and it is the opposite of the question. So we are really thinking of how can we really manage with the people, with the staff we have in ESA, how can we realize all the tasks which we successfully are now supported financially by the member states. So it's the other question, how can we manage all this additional workload? This is our question, more than how to fill the gap. So you see the preparation for Mars sample return. I'm now just looking to the question of exploration. We have the Lunar Gateway discussion and all of this. We have the question of the International Space Station still. So already the exploration is full of tasks, but then we have also the other programs, science, navigation, Earth observation, telecommunication, and also space transportation. So we are not looking for additional work.
Good. Ryan Morrison from Mail Online UK. Is it fair to say issues surrounding the coronavirus led in part to this delay? So due to the fact it made it harder to carry out the remaining tests and checks?
So we discussed all these issues before the virus outbreak was that strong as it is right now in Europe. So, and even at that time we said the probability reduced from day to day. So it's just to say it's coronavirus is the one and only reason, that would be not at all fair. But of course, now in this situation, we see that the coronavirus has also an impact on the preparation, because people from the different places of industry in Russia, in Italy, in France cannot move easily as in the past. So therefore there is also an impact, but I would not like to say the coronavirus is the one and only reason. But it is it has an impact on the mission, yes, and therefore it's. History cannot be reversed. So otherwise, you can ask, what if everything was fine today? Would we still launch, or because of coronavirus to have to postpone? I don't know that answer, but it's ridiculous to look back in history. Let's look forward.
Back to the question on cost, and in particular looking at the budget that was approved in Sevilla. Dave, maybe you could bring us some light on the Mars budgeting part, so that we can tackle a couple of questions related to cost of this delay.
Okay, thank you, Philippe. Let's just say that the budget request that we had for the Mars program at Seville was having fully funded, and so that gives us confidence that we can undertake the Mars sample return activities whilst finishing ExoMars. And it represents an expenditure of, shall we say, about 200 million euros commitment per year for the next 3 years.
Thank you, Dave. Another question here is on the meeting you had, Jan, with Mr. Rogozin this morning. How was the climate of the meeting, of the spirit of the meeting?
So we had a video conferencing because of the coronavirus. I had to postpone or to cancel my trip to Moscow on a short notice. But it shows again that if you have a partner you trust, you can also do it via video conferencing. Otherwise, you need really to be person to person. But we could really exchange on a personal level as well as a more institutional level. We could exchange the situation. I had a clear mandate from the member states of ESA, which I had to convey clear messages, what has to be done. And all of this was accepted. So we also got some protocol of this meeting, which will be finalized so that we have a clear joint understanding how and where to go. And the important thing was that the climate was very positive, also disappointing the result, but we agreed together and not one on the other, and not finger pointing to the other. So we agreed together it's better to go for success than just to go for a launch at this time. So therefore, to have certainty to have a success of the mission is the higher value than to say, yes, we launched it, but it was not a success. So it was positive, very positive climate in these discussions, the personal as well as the institutional one.
ESA is by nature an organization of consensus with all our member states. Is the relation with the partner similar? Is it tough to develop launch missions or programs of this caliber jointly with the partners? And how is ESA dealing with the same kind of relationship with the other partners?
So, as I said earlier, it's in our DNA to work in an international environment, and this is, first of all, of course, with our member states, but also with international partners, East and West, Russia, but also the United States of America, with Japan, with different countries around the world. And for us, the good thing is because ESA has already, by its nature, the understanding how important international collaboration is, but also what are the challenges of international collaboration. Therefore, I think we are an excellent organization for doing those types of cooperation worldwide. And personally, I can just say I love it because we are bridging earthly crisis with space. Not everything, coronavirus we cannot bridge, unfortunately, but we can bridge earthly crisis. And so I can, of course, I have to say the member states of ESA are the ones which are closest to our daily activity, but also to work together with NASA or Roscosmos or JAXA or CSA in Canada is something which is our daily beauty of ESA.
Well, on these concluding words, we are going to wrap up this Q&A session with, again, bear with us with the difficulty of not having a privileged contact with journalists. We will certainly do that in the future as soon as possible. Then we have a better situation. Thank you, Jan Wörner, Director General of ESA. Thanks the two other person, Dave Parker in EXAT in the UK, answering all the questions, as well as Francois Spoto in ESTEC. So again, thank you very much, and this ends the press meeting for today.
Thanks also to you, and all the best, and stay healthy.